So I started this podcast or live session with interesting people because I want to share my process of learning about what's going on with AI in particular, but just tech in general. And I invite in people who really impressed me. And Chelsea was a breakout star at our AI CodeCon, which I put together to help tell the story of why programmers are not actually going to be obsolete. Um, and Chelsea tells that story very well. She is the she leads the machine learning operations team at Mozilla. And she also teaches in the master's program at computer science at the University of Chicago. And she does a lot of stuff for O'Reilly. Her online workshop, Fundamentals of Technical Debt, is on demand. I love that one. It's like exactly classic Chelsea topic. She's got a new one called Leveraging LLMs for Software Engineering that just came out. And then she also does live courses. In particular, she's got one now called Fundamentals of Machine Learning for Software Engineers. But it's not just because of her expertise that I've asked Chelsea to join us. It's because of her common sense. There's so much hype right now. And Chelsea is just the best at kind of going, really? Is that really true? Let's think about it for a minute. She is the reasoning model for the internet. It's like, let me think a little bit more deeply about this. So let's go right to it. I'm going to start with just kind of maybe having Chelsea recap one of the things she talked about at the AI CodeCon, which was this recent paper on programmer productivity with AI. It's referred to as the 26% paper. But anyway, so Chelsea, could you remind us what that paper said and why you were skeptical about it?
Sure. It came out last September from several authors across Princeton, MIT, UPenn, and Microsoft. The title was The Effects of Generative AI on High-Skilled Work, Evidence from 3 Field Experiments with Software Developers. And as you mentioned, it gained some notoriety in the programming zeitgeist as the 26% paper, with the idea being it says that programmers are 26% more productive with large language models than without. The thing about it is that the proxy metric of the paper is number of tasks completed. And the 26 statistic is coming from the fact that the conclusions claim to have seen a 26% increase in that number. Now, what's interesting about that is that the conclusions also outright say that less experienced developers showed higher adoption rates and greater productivity gains in their experiment. The reason this matters is, first of all, because less experienced developers tend to receive smaller work tasks. So increasing the number of work tasks that they do by some large percentage would be a lot easier than if all of the tasks were really major things that might be assigned to more senior engineers, things like spearheading a giant legacy migration or finding a bug in a 167,000 line code base that has already stumped 5 other engineers. It's also the case that more junior engineers tend to receive the tasks that require the least context. So the exact Achilles heel of many of these systems. A large language model can be great at writing a function from scratch, given a series of tests that it must pass, things like that. But at present, the models often can't, for example, identify the insidious scope issue causing data corruption in this giant code base that we talked about. And that's sort of the task more likely to be assigned to somebody with more experience. When we're attempting to measure developer productivity, we ultimately need an accurate proxy for what it means to do a developer's job. I think a lot of our attempts in industry right now to do that are falling short, and they're resulting in the reporting of these numbers that sound concrete for the reason that numbers often sound concrete. Oh, there's a number. We must have done this by some statistically verifiable methodology. And a lot of times we didn't. We did some guesswork. We came up with a number. We reported the number. And then outlets repeat that as fact when in reality, there's a lot of questions still to be asked about how we got that number. Does that help?
I want to do not what I was expecting. We already have our first question. And I thought, rather than waiting to after you and I have talked for, 20 minutes, half an hour going to questions, I'm just going to, if they come up and they're appropriate, let's just go right to them. So CF asks, what have you noticed regarding the code quality when GenAI is used for development?
Yeah, so this is a good question. I teach, as Tim mentioned, master students in computer science, and I ask them a lot of questions about how they use generative AI tools in their work. It's chiefly from this rather than from my day to day work that I've been able to learn anything about this, because my day to day work involves a lot of this, like, track down the bug that already eluded five other people type of thing, in which case an LLM has almost certainly been tried and it has not worked, which is how the thing ends up on my desk. But among my students who are currently trying to use these tools to learn things and be able to write things, um, I noticed some interesting trends. And in particular, I noticed those by asking students how they have used large language models on different assignments, and then witnessing the pattern of the points that they miss in the work that they've submitted. And so the places where I notice the most need for manual contextual understanding and manual intervention among my students and developers tend to be places where there's a relatively complex and consistent data model, scoping issues in the code that they're looking at, relatively high cyclomatic complexity, and code bases that exceed a certain size. Now, that size depends a little bit on the context window of the tool that people are using, but in some of the experiments that I've done with students, we're looking at a context window where the accuracy of predictions of a large language model tends to drop off after the code base that they're using exceeds about 300 lines, which suggests that it ends up not being particularly effective for somebody to point a large language model at a giant code base and ask questions about what needs to be done in that code base. That instead, usage of these tools still relies on developers to be able to scope down the specific issue that they need help with and be able to ask specific questions of a generative AI tool in order to be able to receive accurate answers, which it's then, again, their responsibility to accurately and effectively integrate back into the larger code base that they're trying to maintain.
That kind of leads into a question I want to ask you about your post. How does AI impact my job as a programmer? You make the point that in today's world, writing code is a very small part of the job. In fact, most of the job of a programmer today is reading code that was written by others, whether that's actually, like some package that you downloaded from GitHub, or some legacy code, or somebody on your team, and how AI doesn't really change that. Now you're having to look at code that was written by an AI. So maybe can you unpack that a little bit for us?
Yeah, absolutely. There is a preface that I want to do on this question because it's a thing that we'll come back to a number of times, but it's effectively that the effect that you're mentioning that we're talking about isn't as new as I think we sometimes expect it to be. I think we take kind of a myopic view of the development of AI tooling sometimes, and we're very focused on like the last week to month, maybe 6 months of information about what new things are coming out. But the truth is that when we look back more deeply across trends in computer science and programming generally, we see that that patterns repeat and that effects that are sometimes amplified by the advent of generative AI tools are things that we've already been seeing. And I think that's exactly what's happening here, that what we're looking at is the amplification of an existing cognitive dissonance in our understanding of a developer's role relative to what it actually is. We, in programming, we teach students, we train new hires, we interview our candidates, chiefly on their ability to write code from scratch. But the truth is that as they get onto the job and as they advance in the workforce, especially, their actual main responsibility is reading, analyzing, debugging, and reorganizing code that they didn't write. So one of the things that we talked about in the Superstream, and a thing that I continue to talk to people about, is that once upon a time, writing code from scratch comprised generously 20% of a programmer's professional responsibilities, but like 90% of their education. All the homework, everything we ask them to do is always writing things from scratch, and it doesn't prepare them for that 80% of their time in the editor that's spent on those maintenance, reading, analysis tasks. But now, with the advent of generative AI tooling, the mismatch has become even more stark because those tasks that once required writing from scratch often now include asking a large language model to write it instead. And once that's done, what's the programmer doing? They're reading, analyzing, debugging, and reorganizing code that they themselves didn't write. What comprised 20% of developers' time in the editor now looks like, and I'm guessing here, but I'm going to say something more like 4% of the time. And furthermore, what is replaced, not only that 16%, but also a good deal of the maintenance we were already doing, is specifically targeting the problems on which plugging an LLM suggestion into the code base didn't work. So there's this Ruby developer. His name is Nicholas Means. He does a number of really excellent talks about what we can learn actually as software developers from the world of aeronautics. He did this keynote in 2024 at RubyCon, in which he introduces a 1983 paper by Lizanne Bainbridge. It's called The Ironies of Automation. I'll say people generally object when I bring up any academic paper that's more than like a week old in a discussion about AI. But the reason I do that is that I want to illustrate that the fundamental intuition we need to use in order to leverage these tools effectively, in most cases, it's not new. It's well documented years, even decades sometimes, ahead of the latest model's release date. So this paper that I mentioned, The Ironies of Automation, it says a number of things that Nick pulls out in his talk. I recommend going and taking a look at the talk to folks who are interested. But one of them is that when manual takeover is needed, it's expected that unusual actions are going to be needed. And this quote comes out of the world of like material automation, but I think it's true in software engineering as well. And in these cases, the operator, in that case, that's us, the engineers, we need to be much more rather than much less skilled. And we also need less rather than more cognitive load on us in order to solve those problems. And that's where we end up when we're attempting to operate with AI tooling on relatively complex code bases, or possibly really any code base, but it's especially true in complex code bases. We say the same about magic in frameworks like Rails or Django or Spring. Engineers, we tend to use the term magic as this pejorative term, right? And the reason that we use that term pejoratively when we're talking about frameworks that solve a lot of problems for us is that everything's fine until it's not. And once it's not fine, the precise location and nature of the problem that we're experiencing is not explicitly there in code because the framework is handling it for us. So then we have to understand what's happening under the hood in order to find and fix the issue. I think the same can be true when we're trying to use generative AI tooling in order to solve some of our programming problems. I've been giving this talk over the past few weeks about evaluating patterns in large language model outputs. And part of the goal of that talk is to help developers understand exactly that, how these models are trained, how they generate sequences of text, and how they can use that understanding of how these models generate sequences of text to predict what they are most likely and least likely to be able to do for you correctly. There's a number of visualizations I've developed for it. I've put them into the on-demand course you mentioned that just dropped, leveraging large language models for software engineering. So if folks are curious, I wish I could show you on a stream like this some of those visualizations, but you can find them in that on-demand course. So if folks are curious, I'd recommend taking a look at that.
That's great. Hey, I'm going to jump to another attendee question. FB asks, do you think we should start drawing a line between good and bad generative code, where good code includes pure functions, clean HTML, and styles, while bad code comes from AI replicating the structural flaws of existing frameworks? Isn't that latter group where most of the tech debt is actually being generated?
This is a good question. I think, and this is a thing we'll talk about some later too, but I think there's a tendency among software engineers to identify specific practices as best practices and then attempt to use those universally, resulting in a fair amount of tech debt in my experience, in fact, coming from situations where we've used something that's like generally a best practice, but we haven't bothered to stop and interrogate what we mean by generally. That is, generally means in a certain trade-off environment that is maybe the most common trade-off environment, but is not the universal trade-off environment. And so I think a lot of technical debt doesn't come necessarily from like the use or the not use of pure functions or the use or the not use of state. It is instead the misapplication of specific structural entities to situations where they're not appropriate because we heard that they were a best practice. I think that part of the reason that large language models regurgitate some of that is that precisely the way they are trained results in a lot of outputs that effectively regurgitate a global average of what the internet said is the right thing to do. Now, a global average of what the internet said is the right thing to do is not the same as what you should do, individual developer. I think the task still falls to us to understand the trade-off environment that we are in and select the appropriate practice for our particular situation based not on whether the internet says it's a best practice, but based rather on whether its strengths line up with the most important needs that we are facing in our trade-off environment, and its weaknesses miss or are mitigated in our trade-off environment as well. I think that's a skill that's always been important for developers, but is even more important now with the use of these tools.
Yeah.
There we go.
I have sort of a related question, which is, and this is just sparked by what we're just talking about. When you get LLM output, it's easy to kind of go, it works, without thinking more deeply, is it what I really wanted? Mm-hmm. And I think back to one of my earliest lessons in programming was from a guy named Andrew Singer when I was writing the manual for ThinkC, which was the first C compiler for the Mac. And Andrew said, the art of debugging is figuring out what you really told your program to do instead of what you thought you told your program to do. And,
yep.
And I think about that with like, okay, I gave some instruction to my LLM and it did some version of that. But was it really the right thing? Was it really what I wanted? Was it really what I meant? And how do you get that perspective?
Yeah, that's an excellent question. And I think is a skill that developers need, especially right now. We'll talk a little bit more about evaluative skills later. There's a piece on my blog where I talk about this in a little bit greater detail. It's called, I think I'm going to get this title right. It's called Best Practice is Not a Reason to Do Something. And there's a header image of Oscar the Grouch from Sesame Street, which I'm very happy with because I loved that show growing up. I don't know. I think probably the text of the post makes me sound a little Oscar the Grouchy, but I do think that it's really important for developers to have skills specifically in, first of all, understanding what are my needs in this situation? What are my vulnerabilities in this situation? And then being able to evaluate for any solution, either that they come up with individually, that they come up with in a meeting, that they get from a large language model, wherever, they need the ability to verify how that solution is going to interact with those trade-offs, is going to interact with what those needs are and what those vulnerabilities are. And I think that sort of analysis of whether the situation merits the given solution is a step that we're a lot of times skipping right now as software engineers, when it would make a lot of sense for us to take a step back, understand those pieces, and then use them as evaluation criteria for the solution that we get from a generative AI tool or from our own idea generation processes.
Yeah, well, there's a related question from IA who said, will using LLM or generative AI tools too much dull software engineer critical thinking? And I guess the question there is, what should we do about that also?
That's a great question. It's a question that I've wrestled with as my students have attempted to figure out how to use these tools. I wrote a blog post recently. It's called "The Homework is the Cheat Code," but it's about how I have come to think about generative AI policy in my classrooms. And a lot of it is based on exactly this question, because I think that my experience of using the tools is that in the moments where they are not able to provide me with the appropriate solution to my problem, the skills that I need in order to arrive at the appropriate solution to my problem anyway are skills that I have developed by working through easier problems than this one manually, which in my case happened to occur before we had this advent of widely available generative AI tools. My students do not have the opportunity, I'll call it the opportunity, to exercise that manual decision-making skill set in a world where they could not, in a world without the option to align that skill set in favor of asking a large language model. And they can arrive at the solution by asking a large language model. But the point of the homework assignment was not ever the solution. I don't actually need insertion sort implemented for my benefit or my employer's benefit or anybody's benefit. There's already insertion sort. The reason that I ask a student to do something like this is because the outcome is the cognitive development and the skill development that comes out of them doing that task. And I think we were seeing actually relatively little on this up until relatively recently, but I think recently developers have been talking more about the effective ways to leverage these tools without the risk of completely losing or not developing that skill set. I think the hard part is that particularly early career developers are exposed to this, as Tim described it earlier, like very hypey zeitgeist about this tool, but they have no inoculation of actual technical experience against anything that they're hearing. And so the takeaway that they are getting from this very hypey zeitgeist is like, if I'm not using this tool for everything, I am going to be replaced. And part of my hope in educating people about these tools is to add quite a bit of nuance to that understanding and talk about, okay, in a generative AI enabled workplace, what skills do you as an engineer still need? How do you develop those skills? How do you work on those skills? And I think that in some cases, yes, developing that skill set involves completing problems that could be completed more efficiently from a time perspective with a large language model, for the same reason that developing muscular strength involves manually lifting barbells that could be moved much more efficiently with a forklift. Because the point was never the relocation of the barbell. It was the development of the strength and the mind-body connection needed to move the barbell.
I love it. You know, that makes me think of one of the questions that I was planning to ask you, but you have a great post where you talk about what are the essential skills of a developer. What is it that people really need to learn and know, going forward, even in the age of LLMs? Can you talk to that a little bit?
Yeah, I can. So when it comes to individual developers,
By the way, you might remember the name of the post. I don't remember what it was called, but you had a great one. But
yeah, absolutely. There are, well, I'll think about it. I'm sure it'll come to me, but individual contributors, software engineers, what do they need to be able to do these days? My advice on this, I think, is informed by my experience as an individual contributor myself, working with other individual contributors, a fairly large network of people I meet at conferences who are doing various things with these tools, and then also helping students, helping early career software engineers with this kind of thing. And I think there's a grave need, particularly among engineers, to focus on basically 3 specific skill sets. So first, we have investigative skills, the ability to scope down the specific area in which we are facing a problem and ask specific questions that help lead us to an answer. We talked about this just a little bit earlier. I think this skill set is the primary driver of one's ability to gather context on heretofore unknown code. This skill set is also the primary driver of one's ability to debug a program that's not working as intended or expected. And finally, and most relevantly to this discussion, I think this skill set is the primary driver of one's ability to systematically query a generative AI tool to useful effect in an increasingly complicated code base. Because the large language model can generate answers for you, but you have to know how to generate the right questions. I think, if I could, write a whole book called Investigative Engineering if I thought that it would sell, because I think there's no professional development area more important than this one for engineers to be working on right now. So that's my first skill set for individual contributors, is investigative skills. The second one is evaluative skills, which we've also spoken to a little bit apropos of a question that was asked earlier by someone in the audience. And evaluative skills to me comprises the ability to select from a range of options based on how their benefits and shortcomings stack up against our decision criteria in our specific situation. I think engineers are mostly underskilled at this and lean instead on what they've heard as a best practice without understanding why exactly you should do that thing, and therefore when it's maybe not worth it or even a bad idea. I think the skill set also dictates the degree to which we can effectively and efficiently sort like useful and not useful answers from a generative AI tool, coincidentally. So we've got the investigative skill set, we've got the evaluative skill set. The last one is the innovative skill set. Innovative skills give us the ability to search for and identify shortcomings in our status quo or our available options, and then consider solutions that haven't been tried before in order to address those shortfalls. Machine learning models, the way they are built, the way they are architected, the way they are trained, the way they fundamentally work, is to replicate patterns. They're not designed to generate new patterns, which is exactly what you need in order to move the state of the art in implementation a step forward. I think that job of innovation still falls to us. And it's critical to our success as practitioners in the industry with or without generative AI tooling, frankly. But I think that's the case for all of these skill sets, in my humble opinion. I think that regardless of you or your company or your boss's stance on generative AI tooling, investigative skills, evaluative skills, and innovative skills are critical skill sets that make an outsized contribution to somebody's ability to perform and to advance in a software engineering context.
Hey, LG asks a related question. What do you think about the feedback loop when people start using AI to resolve problems instead of Stack Overflow? Will it lead to the situation that AI won't be able to deal with new programs that have never been reported at Stack Overflow? Is there a negative feedback loop there?
Yeah, this is a good question. I think that, yes, there is one of the vulnerabilities of large language model usage is that they can only replicate patterns that they've been trained on. And that's a vulnerability that itself is not new. You know, we've used Stack Overflow for as long as we've had it. And one of the things that we know about it is that solutions that are too old are likely to be out of date for the modern tooling. And if our problem is with a library that is too new or the version is too new, it's relatively unlikely that we'll be able to find our question already answered on Stack Overflow. Now, the utility that Stack Overflow provides us is that we can then ask that question and eventually somebody can answer it, you know, among all of the other answers telling us that we shouldn't be doing it that way and asking us why we are doing it that way and answering questions that aren't the one that we asked. But that's one of the utilities that Stack Overflow provides to us, is that we have the opportunity to ask new questions, and a human can provide us with a new answer, or other people who are trying to figure out the answer can work with us. It's precisely on those sort of collaborative projects and information generation projects that human expertise is still so valuable. And it's a thing I end up emphasizing in my classes, because that information retrieval step we now have more tools for, but the information generation step, we still need somebody proactively trying things and running experiments and figuring something out in order to make that happen. Now, do I think that it's the case that people are no longer going to be able to find solutions to novel problems as they query a large language model? This is a great question, and I think one that comes down to the way that our workflow incorporates large language models. I would like to believe that if folks are unable to get the answer through an LLM-enabled workflow, they possess fallbacks and skills that give them the opportunity to identify the answer by other means, either by turning to something like Stack Overflow to ask a new question, or by using the investigative skill set that they've hopefully developed after having read my very prescient answer to the previous question, and figuring out how to get it done for themselves. I think the step that still leaves to chance, and I'm not sure how it will be, I'm not sure how this will be resolved yet, is then how those new answers continue to make it into the tooling and into the workflows that people are using, such that it left shifts their ability to find the answer into earlier in their workflow process. And I think that the sort of like easy answer to that question is, oh, we just keep retraining the large language models on new data, which might be the case. Although a thing to understand about large language models is that the base training step is quite time intensive and quite computationally expensive. And so wholesale updates like that happen like it would be very computationally expensive to have just like a nightly CI job that base trains the entire large language model on everything that came out of the internet in the past day. That'd be very difficult to do. So I think that step of like how the things that we still have to figure out make it into the regurgitation schema remains to be figured out for our industry. Does that help?
It strikes me that there's an opportunity to reinvent Stack Overflow for the age of AI, or do something else. And I want to go back, actually, it got to be better part of 30 years to the one of the first bots that was sort of used for developers. It was on the Perl IRC channel. This guy named Kevin Lenzo, who was at the time at CMU, wrote this Perl bot. And then basically, whenever somebody answered a question in the channel, somebody could say, hey, and the bot was called Perl, P-U-R-L, I think, as opposed to P-E-R-L. Hey, Perl, remember that one. And then the bot could regurgitate it if somebody else asked the question. But what Kevin introduced was a very clever hack, which was that Perl also could be told when it answered, somebody else could say, actually, Perl, that's wrong. Replace it with this answer. And so it was this sort of social, coding, community. And I do wonder if there's an interesting opportunity for, people go, okay, I got this answer out of my LLM. I think it's wrong. And here's what I think the right answer is. And is there could we build some mechanism for that kind of human social feedback? I don't know how we do it, but it sort of strikes me as a really interesting opportunity.
That's a good question. The broad socialization of supervised fine-tuning, I think, has begun at some organizations that are working on making it easier for folks to provide feedback on the answers that these sort of tools provide. The way that I've generally seen this show up in user interfaces so far is that I ask a question and then I receive 2 to 3 separate answers to that question, and I'm asked to select the one that I find the most useful. But so far, I have not been served an interface that asked me to then provide the answer that ended up being useful if it wasn't any of those 3. I wonder whether that's something that we'll start to see in the future.
That's a great idea. Okay, a number of people have been asking about security. Most recently, Eleanor Mitch says, I'd like to know as well about security concerns with LLMs. How is data is being used to train, being shared? With everyone so enthused about dumping things into LLMs, I'd like to hear your thoughts on LLM and AI security.
Sure, absolutely. Well, yeah, I think this is a hot topic in large language model development. And I think for good reason. We've already seen, cases where the use of the tools without understanding how they work has resulted in the potential for vulnerabilities, the potential for security breaches. For example, some folks at Amazon were querying an LLM and found that it was able to regurgitate code that looked eerily similar to proprietary code at Amazon that shouldn't have ever been fed into a model like this. And the suspicion is not that the model was trained on data that it wasn't supposed to be trained on, but instead that it gleaned the structure of that code from an input that a customer made at some point. There have also been cases where folks asked a large language model about a library to help them solve a specific problem. And for reasons that I get into in that on-demand course that we were talking about, leveraging LLMs for software engineering, proper nouns, things like names, such as names of libraries, are things that a large language model is particularly vulnerable to hallucinating. Now, if a large language model tells you you should go try this library, and then what you do is install that library and start running things in it, well, maybe it's actually the best case scenario for you to try to install the library and discover that the library doesn't actually exist. But what if instead somebody who's interested in infiltrating your systems does their own prodding of a large language model to figure out what library names it's likely to hallucinate? And then they build a library with that name that includes security vulnerabilities specifically designed to be able to access your system. That's a vulnerability that we've seen. That's a vulnerability that we've seen talked about as well. And that's even aside from, I think, the general case that people are talking about when they talk about security vulnerabilities, which a lot of times I think is like putting code that an LLM generated into their code base and not recognizing the security vulnerabilities associated with the use of that implementation, which is also, of course, an issue that we need to deal with, and one that I hope is addressed in our development of evaluative skills for this kind of thing. And it's one that's a big enough concern that even organizations that are specifically focused on figuring out how to use generative AI tooling in order to improve their workflow process, ThoughtWorks comes to mind. They recently came out with an article where they were talking about some of the ways that they've tried to use large language models in their development workflows. They are explicitly excluding tasks that register a security risk from those tasks for which they are using large language models to devise a solution. I think it's an issue. I think it's an issue that we have the opportunity to address by better understanding how the tools work and using them judiciously, as is often the case. Expecting a giant industry to universally use a tool judiciously is optimistic. Is optimistic.
Yeah, in fact, where they have incentives to use them injudiciously, to move fast and break things.
Right.
So, for those of you who are interested in security, my guest last week was Steve Wilson, who's the author of the Developer's Playbook for Large Language Model Security. And he talked about a lot of those issues. So if you're a platform subscriber, you can go back and watch that even if you weren't there. We will actually have the audio track only on the web page for that, but it's not up yet. So anyway, I think the security questions are huge. So thanks for asking that. Let me just take a moment for you, Chelsea, to sort of advertise Mozilla. You work there. Mozilla played obviously an incredibly important role in the democratization of the web. You know, many people don't remember this, but there was a time when it looked like, Microsoft was going to become the dominant provider of both web servers and web browsers. This is before Chrome. And if they controlled both ends of the connection, they were really trying to reproduce their Windows monopoly. And, along came Mozilla with Firefox and changed the game. What do you think, or what, not just you, well, you personally, but also, Mozilla in general, about what do we need today? Because we have a bunch of people who are saying, hey, we're going to make a world where we control it all, and that dream of monopoly is so deep rooted in tech today.
Yeah.
And so here's an organization that played an enormous role in the public internet and keeping it a public. How do you see that for AI?
Yeah, it's a good question. It's precisely that kind of like big picture public goods thinking that drew me to work at Mozilla back when I was interviewing in 2020. And I do think it's the hope of the organization to contribute to the conversation around these tools. I think it is hard to get around the fact that, candidly, the creation of generative AI tools relied on a series of transgressions upon the internet's norms of data ownership and even data privacy, which is one of Mozilla's core values. And whether or where accountability might lie for that or what might be done, I think still remains unclear. But I think another of Mozilla's core values is a dedication to open source frameworks of thought and creation and collaborative, decentralized contribution models, for code, for ideas, for the future of tech in general. And to the extent that a generative AI future might succeed in achieving the impact and legacy of something as storied and fondly recalled as the internet itself and the browsers that made that accessible to the general public, I think a shift towards those values is going to be absolutely crucial. I don't know what that would look like at this point. In part because the leverage points, I'm not confident match up with the incentives for that to happen. But I do know that a lot of people, many Mozilla engineers among them, myself among them, would really like to see it. I also teach in, as you mentioned, the master's program in computer science at the University of Chicago. And I teach this elective in the spring. It's called Topics in Software Making an Impact. In that class, we do a bunch of exercises on precisely this issue. So we talk at length about technical innovation, how it happens, when it happens, why it happens, whether it happens, what are the conditions under which it happens. We also practice investigating and mapping the impacts of a technical advancement. We start with cars, then we do web browsers, then we do generative AI tools. And the exercise I'm asking of students is to identify the drivers and incentives and leverage for in these advancements, and then consider interventions that can enhance positive impacts or mitigate negative ones, or both. And it's through that work, at least as much as my day job work, I think, that I feel empowered to contribute to the kind of thinking that Mozilla has always stood behind, that created this sort of shift in the future of the internet that you described earlier. I think the tech industry at large, the way we educate into it and select into it, has for a long time neglected the importance of developing critical thought frameworks for facilitating things like big picture public goods thinking. And we could get into why I think that's happened, but it's like maybe out of scope for today. But I'm hopeful. I think I'm maybe unrealistically hopeful that drilling that specific skill set in the next generation of engineering leaders will eventually result in more decision-making that incorporates it in the tech industry at large.
All right, I'm going to ask the question from JG, who's just came in. How important is it for software developers to know under the hood of an LLM, and to what depth? And what's a good source to get that in-depth knowledge?
Yeah. This is an interesting question, because I think there are a number of levels of detail that we can talk about the design of large language models and the products that surround them. I think that it is valuable to have some understanding of the general picture of how those things work. I think a deep knowledge of the underlying architectures of large language models themselves is unrealistic to expect, like, large populations of people who aren't actively developing these things to be responsible for. And I also think that it's not necessary in order to be able to use tools like this judiciously. However, I do think that there is value in understanding enough about how they work to be able to predict their strengths and vulnerabilities on their responses with some accuracy, and also to be able to use them effectively as consumers in a technical work environment. So I think that there are a couple of resources that I think are useful for that. Chip Hoyne has a great book, AI Engineering, out through O'Reilly, that I think is good for this, that I read, that a couple people recommended to me at O'Reilly itself, but not before I had found a copy of it in the back of my friend's car and read about 3/4 of it. It's a great book. I recommend it. And then the on-demand course that I think it published on June 11th for me, called Leveraging Large Language Models for Software Engineering. The entire initial part of this course is dedicated, to the best of my ability, to illustrating and describing these concepts specifically to a software engineering audience at the level of detail that I think is deep enough to give you the understanding you need, and high level enough to not require somebody to like go back and take a mathematics course in order to be able to understand it.
Yeah, I can't resist asking a self-serving question. You mentioned an O'Reilly book. You mentioned an O'Reilly on-demand course, and you also do live courses. Can you kind of, we have these multiple modalities for people to learn. Do you have any thoughts on the trade-offs and differences and benefits of each?
Yeah, absolutely. So, of course, there's so much material available on O'Reilly. There are the books, there are the on-demand courses, there are the live courses. We've talked a bit about the on-demand courses. Books, I think, often thought old-fashioned in sort of general zeitgeist, which I find appalling, because a lot of times what somebody's doing in a book is they are taking 2 to 3 decades of mistakes that they have made and condensing that into a useful, legible little package for you to not make any of those 20 years of mistakes. And so I just absolutely love the book format. It's one of my favorites. But then we also have the live workshops. I do a number of live workshops through O'Reilly. I think the most imminent upcoming one is an edition of Fundamentals of Machine Learning for Software Engineers. But to me, the lovely thing about live workshops and the thing that makes them unique and special on a platform like O'Reilly is the interactive element, which I use quite a bit in my live workshops. So I do a lot of interactive work in there, and the questions from the audience drive quite a bit of the content in one of those live workshops. What those workshops give you is access to an industry expert in order to ask your specific questions and tailor the content to you. And it's also the case that a lot of times on-demand courses, books, other like asynchronous material like that comes out of live workshops. So for example, we've talked a fair amount about this on-demand course, leveraging large language models for software engineering. It's an on-demand course now, but before that, it was a live workshop. And I came to a lot of the material in that on-demand course by listening to the questions that I received repeatedly in the live workshops. That live workshop precursor was, in addition to being a way to give people information, a research endeavor that gave me the opportunity to understand precisely what it is that people at other companies outside of Mozilla, outside of wherever I'm working, need to know or are trying to learn so that I can provide the most useful version of an asynchronous bolus of information about this topic.
All right, awesome. Let's go back to audience or attendee questions. Maciej Wojcik asked, how can we systematically implement AI assistance in software development? What patterns do you recommend? I'm looking for insights, not just from the perspective of an individual programmer, but from the viewpoint of the entire team or the overall software development lifecycle process. But I want to hold your answer because I want to come up to another one, which was very related that just came in. Gary Penniman asks, are there any published set of best practices or recipes or collections of prompts for GenAI agentic coding? For example, step one, work with LLM to create PRD. Step two, work with LLM to create tech spec. Step three, build, test code, etc. It seems like everyone is trying to figure out these prompts and process out from scratch. Any guidance or resources in this area? So these are two questions that really about, are there any best practices that are emerging about how to use LLMs more effectively in the overall process?
Yeah, this is an excellent question. And I think it's one that we're still coming to, in part because models are still in flux, and also because this is relatively new. Working with these tools is relatively new. And I think that to the extent that we are able to build a series of practices for working with them, it will need to be fluid for the same reason that, for example, if you were to put together a series of processes around working with a search engine in order to build a code base, it would need to be fluid and situation dependent. This is a topic that dominates a lot of the discussions in that live course that I was just talking about, Fundamentals of Machine Learning for Software Engineers. That course began as a walkthrough for software engineers to understand the steps involved in incorporating machine learning models into a software workflow, not just large language models, but any machine learning model. And that included data preparation, understanding the types of models that might get used, choosing evaluation criteria, evaluating models and libraries, and then monitoring results to ensure a high quality product. When I first developed that course, a lot of it focused on, for example, if we were integrating with a classical machine learning model based on tabular data, and things like data preparation meant I need to understand how to deliver clean tabular data to a machine learning model. But now data preparation includes a lot of asking the appropriate questions and asking questions at the appropriate scope. I think that when it comes to a lot of the early steps in the software engineering process, quite a bit of manual intervention is still necessary in order to be able to achieve the thing that we want to achieve. For example, if what we're trying to do is determine the specifics of a feature that we need to develop, I think asking a large language model to be able to generate that for you and then uncritically using its results has resulted down the line in a number of cul-de-sac moments for teams where they find themselves moving in circles and not getting anywhere and not really understanding why. And a lot of times the reason for that is that there are details that, for example, that PRD has missed that nobody then added back in, because it turns out that that vision step, that innovation step, that figuring out what needs to happen that's different than everything that has happened before is still a skill that falls to us as software engineers. But that's a thing that we end up getting into in more detail in that live course now. Although it initially focused on classical machine learning models on tabular data, now through free-form discussion and now some of the changes to it have trended toward a lot of research at the intersection of large language model use and developer productivity specifically, and less a specific script of prompts that you should use with the tool, but instead towards patterns of errors developers can expect while working with large language models on large-scale software products. When it comes to resources about this kind of thing, lists of prompts and that sort, I'll be candid. I think that we have a lot of conflation of terms that makes good resources hard to find. And I think we also have an incentive structure that makes good resources hard to find. Right now, it feels like a good move from a business perspective for folks to have an opinion publicly about large language models. And that results in a lot of things being said that are based on either speculation or at the very least unrigorously collected information. That has been the standard of quality that I personally have seen in most lists of prompts to use. These like 50 super effective prompts to use lists are not made by testing thousands of prompts and figuring out 50 super effective ones. They are made by speculating on 50 prompts that you can use because it feels like there's a benefit to somebody's reputation to having published a 50 super effective prompts to use list, unfortunately. But I also think it's the case that we've conflated this term like AI engineering to some degree, particularly in sort of this part of the software engineering discipline where we're trying to figure out how to use these tools, because I think there's sort of three career trajectories, or at least tasks, that we needed to be able to differentiate between these tasks. And people are finding resources about all three of these tasks while trying to better understand any one or even all of those jobs. First of all, you've got literally being a machine learning engineer who is building generative models. So that's one thing we sometimes use the term to refer to. We also use it to refer to being a software engineer working on systems that integrate with generative model APIs or SDKs. And that includes people who are, for example, getting like the OpenAPI Python library and integrating with it in their regular Python. But it also includes the people who are building the products that incorporate and serve these models. That is the people who are working on the software as a service application that serves the GPT-4 model, right? ChatGPT itself. That's a product. It's not just an LLM. It's a product surrounding an LLM. The third way that we are using this term is to describe being literally any kind of tech-related professional accessing the user interface of the tools built by the people doing 1 and 2 during the course of our workday, where we are not ourselves maybe integrating with these tools or building these tools. I would love it if we had more specific terminology to describe each of these three things. And I think we could come up with that terminology, but I think a much harder task would be socializing that terminology so that we're all using the same terms for each of these things. But I think right now, a lot of times when we talk about how to do AI engineering, the person asking might be talking about number 2, and the person answering might be talking about number 3. And so I think it's really important for us to be specific in this. And I think that level of specificity is just, I don't think that the standard of quality for resources on this are reaching that level of specificity for me in a lot of cases right now. I do think in terms of resources, you asked about resource recommendations. I think some of the ones that we've discussed prior on this interview are in fact the main ones that I would recommend. I've read a lot about this stuff. I read a lot about this stuff. And I have not found strong contenders that compete with those resources right now.
You do seem to read a fair number of technical papers, and how do you pick which ones to read? And what's your source for those? Is it just on the socials, or do you troll archive, or?
Yeah, it's a good question. It's one to think that I think I maybe have a discouraging answer to, but I haven't found like any one individual newsletter or online community to be a comprehensive summary here. But here's what I do. First, I subscribe to a number of online newsletters from several engineers and journalists whose analysis and opinions I've come to respect. And I'll say for all of them, I tend to take what they have to say. Name some names. Okay. So there is a journalist named Ed Zitron, Edzitron. He writes this blog called Where's Your Ed At? And I'm going to go ahead and say that his online I haven't met him personally. His online persona is like very crank dad energy. So keep that in mind when you're reading his stuff. But he does a fair amount of stuff about sort of like the business implications of the advent of generative AI tools. And I think some of the things that he has to say are really, really prescient about it. For example, he wrote a piece, he published it just a few days ago, I think, and it's called Sincerity Wins the War. If you were to ask me right now what single 5 pieces from his blog you should read, this would be on my list. He talks about the way that the zeitgeist tend to regurgitate things that powerful people at various companies have said without necessarily doing any critical analysis of whether any of those things are true, or even like who benefits from the public thinking these things are true, and whether there's any overlap between the people who benefit from the public thinking this is true and the person who said that this thing is true. So I think that if I were to recommend somebody, and in particular a specific piece, that's one that's coming to mind for me right now. I also have a subscription to Journal Club by Malcolm Diggs, originally by Malcolm Diggs. Now I think there are a series of editors on there. It's not AI specific, but what they do is they break down one paper every day. They send it to your inbox. Their explanations are really great. I think for people who just love learning and keeping up on what's happening in scientific and computing research, but have really limited time, that's like my number one recommendation. They're so good at what they do. And it's reading through their archives has been really useful to me. So I think that those are two in particular where I would say if there are two like centralized newsletters that I recommend at least being in at the moment, I think that for a relatively I don't know if I would call it. Yeah, for a relatively pessimistic angle, I would read Ed Zitron. For a relatively balanced angle, I would look at Journal Club. For a relatively sort of like optimistic and vision forward angle, I don't even know if I would call it optimistic, but for one where people are genuinely figuring out how to use these tools, I think Nicholas Means, the Ruby developer that I mentioned earlier, is somebody who's doing interesting things with this. I think that honestly, O'Reilly has managed to collect some of the folks from whom I've seen the most high quality information on this stuff. And so I understand that I'm like on Tim O'Reilly's stream right now, but that's actually what I would recommend for like forward thinking, but relatively measured opinions about exactly how to use these things effectively.
So unfortunately, we're out of time now, Chelsea. I'm going to throw in really quickly 2 others. From a high-level executive perspective, I love Ben Thompson's Stratechery, and Gergely Oros's The Pragmatic Engineer would be 2 that I would add to the list. That Chelsea, you might disagree, but you don't have time to answer, so because we're out. Sorry, and I'm sorry we didn't get to all of your questions. Thank you all very much for joining us, and Chelsea, thank you so much for taking the time to be with us all.
My pleasure.